Hi everyone, and welcome to this video in which we will be covering interfaces, often referred to as a legal form of multiple inheritance. This video continues on from another video about single inheritance, which should be watched as a prerequisite before this one, for those who are unfamiliar with inheritance. If you've already watched that video or are already comfortable with single inheritance, then keep watching. For those who watched the last video, we left off on the question of how we might achieve multiple inheritance. Well, Java doesn't actually permit multiple inheritance where a subclass can have more than one parent class. Instead, it allows us to use something called interfaces, which enables us to achieve the same result. Interfaces are often thought of as a legal form of multiple inheritance, and throughout this video, we will see why that is. This video will take a closer look at interfaces and provide you with examples of when and why you might want to use them. So let's get started. In the previous inheritance video, we used the example of an online university system, where students and teachers were able to log in and do various tasks like check their grades or give feedback. Let's imagine that we wanted to extend the use of this system, not just to university students and staff, but also to general employees, to be able to enter details about themselves, maybe their name, email address, and submit the number of hours that they've worked that day too. But now, suppose we have a student that has managed to swing a part-time job at the university. This student will need to be able to perform the same actions as other students on the system, but also actions afforded to those who are general employees too. We might want to have an employee class which details behaviours reserved for employees, and a student class doing the same for students. This sounds like a case that we might consider using inheritance for. Let's do an is-a check to confirm. A student worker is a kind of student, and a student worker is also a kind of employee. That seems to check out. So instinctively, we might think to do something like this, which is to allow the student worker class to inherit functionality from all the classes that it has an is-a relationship with. But a big problem with this is that if the two parent classes contain implementation for the same method, how would we choose which one to use, or which one would get priority? This kind of ambiguity can cause problems and would be difficult to implement solutions to, so Java doesn't actually support us doing this directly the way that we've done here. Instead, it allows us to use something called interface types, which the compiler can deal with. Interface type objects typically contain abstract methods, but from Java 8, we do have the ability to include concrete default methods and static methods for use within the interface only. Because interfaces allow us to achieve a very high level of abstraction, as we don't define anything in these interfaces, they can be used to help us avoid the ambiguity that comes with the idea of direct multiple inheritance between classes. This level of abstraction also means that interfaces are able to extend multiple other interfaces. And finally, an important thing to note is that if a class implements an interface, it has to define all the methods declared there in order to run successfully, except if that class is an abstract class. Here is an example of how we might define an interface. As we can see, the word class present in our concrete class header is not present in our interface header. And in addition to this, our interface does not define any of its methods, whereas this is defined in our concrete class. Taking our university system example once again, we said that we want our student worker to be able to do some things that employees can do, but also things that students can do. For example, a student can submit work when they log onto the system, and an employee can log the amount of hours that they worked. So we'd like our student worker to be able to submit work, but then also log the amount of hours that they've worked. Let's see how interface type objects can help us achieve this. First, let's create interfaces for the two classes that acted as parent classes for our student worker in the previous example, student and employee. To create an interface, rather than putting class in the declaration up here, we would write interface. Methods inside these interfaces will be the methods that we want our student worker class to be able to use from what would have been the employee superclass and the student superclass. So from our employee behaviors, as a student worker, we want to be able to update our address and log the number of hours worked. And from the student behaviors, as a student worker, we wanted to be able to update our address and submit some homework. Normally, we would need to put the keyword abstract in front of abstract method declarations, but because this is not an abstract class but an interface type object where all methods must be abstract, it means that we don't actually have to put the word abstract in the method header because all methods here are assumed to be abstract by default. Now, because we've not defined anything within these method bodies, if we were to have a method that appeared in both these interfaces, as we can see with the update address method, There would be no ambiguity, as implementation is going to be done in the child class of student worker, where the method is defined. This means that there will be no confusion for the compiler on which update address method to follow, because it's only been defined in one place, which is the student worker subclass. When defining an interface method, we also need to specify whether or not that method should have any parameters when it's implemented in the child class. For update address, we want to be able to accept the new address of whoever's calling that method. So let's just add that parameter in. And specific to employees, we want the employee to be able to log their hours, so we can add a parameter hours to this method. Now we can create our student worker class. When we create it, we use the keyword implements in the same place that we would have used the extend keywords for inheritance to say that this class will be implementing the methods from a particular interface. In our case, our interfaces are called student and employee. If we have more than one interface, we separate them with a comma. So here let's just go ahead and define the student worker class. In the constructor here, we can take a first name and a last name, and we can move on to define the methods that we declared in our interfaces. So for update address, let's use the person's first name and last name to give them a personal welcome, and then provide them with a confirmation of their updated address. For the log hours method, we're just going to show the user confirmation that their hours have been logged and do the same for submit work. Now let's test this out. In our test class, let's make a new student worker object called Stu and give it the name Joe Blogs. Now we can call each of the methods that we implemented from our two interface classes on this student object. So that would be log hours, submit work, and update address. Let's give log hours an input of 5 and update our address to 123 Fleet Street, for example. Now let's run that. So as we can see, through the Stu student worker object, we can access all the methods in the two interfaces and implement them how we like in the student worker class. This is giving us the same result as if we were to have two parent classes implementing these methods for us. The idea of interface types is also what underpins another pillar of Java, polymorphism. Without interfaces, polymorphism would be much harder to enforce. Interfaces allow us to group classes together in a way that is independent of implementation by allowing our objects to take on many forms. In simple terms, this means that we can have many implementations for a particular function depending on the type of object that is using it. Though we won't go into detail about it here, as we do cover it in another video, it is something to be aware of in order to help you see the bigger picture of how powerful interfaces can be. So that's the basic idea of how interfaces work and how they can help us achieve multiple inheritance.